Okay, good morning, everyone. If you can hear me okay, would you please type yes into the chat window? Okay, great. Everybody seems to be able to hear me. Well, good morning again. Just a couple business items before we get started. Uh, so yesterday, last night before I went to bed, I sent you all an email that it indicated that HAC has decided to keep its campuses closed for the remainder of the semester. That's a difficult decision, and what that means for us is, in fact, that we will be finishing the semester online. All lectures at this point have to be online, and we're going to have to do all of our testing online. So last night I sent you a link to a testing website called ClassMarker, with instructions of how to create a free account and to take a practice quiz. Have you at least seen that email and know what I'm talking about? Okay, wonderful. I'm getting yeses from you, so that's fantastic. Remember, folks, please try to stay up to date on your email. Make sure you check it every 1 or 2 days in case new information comes out. Okay, so I'll leave it to you to please create a free account on ClassMarker over the next few days, and I'll ask you next week how that's going. I think you'll find it a pretty intuitive website, and that's the website we will be using for both lecture and lab exams for the rest of the semester. Okay, at this time, do you have questions? Please type them in to the chat window. Okay, I'm seeing Pam's first question. Can we use the old account? The answer to that, Pam, is no. You have to create a new account because the new account will be linked to your current course, Biology 121. Your old account is linked to Biology 111. So you do need to create a new account. Any other questions, gang? Okay. I noticed that probably only about half of our class is with us this morning, and that's okay because there's a lot of new challenges and responsibilities. If you have friends in class that you are in contact with either through email or that you call with telephone conversations, please check up on them and make sure that they're okay and encourage them to stay up with class. It's really easy at this point to get really frustrated with things, and you don't want to do that. You want to stay as focused as you can so we can all finish this semester. Okay, so if you have questions moving forward in the lecture here, please feel free to type them into the chat window. Also, if I'm moving too fast or something, go ahead, unmute your microphone and just speak up and interrupt me. That's okay. So what we're going to do at this time is continue our discussion of chapter 6. I'm going to finish up a quick description of some of the cells we find in the bone tissue, talk to you about some of the features of compact and spongy bone, and then we're going to go into the synthesis of vitamin D and the maintenance of calcium homeostasis in the bloodstream. So that's what's on top for today. So bear with me just one moment as I begin to share my screen with you. Okay. If you can see the Word document on the screen, please give me a thumbs up in your video window. Thank you. Okay. All right, gang. At the end of last class, we had just got started describing some of the cells you see in figure 6.2, figure 6.2 on page 174. Okay, and we mentioned the osteoprogenitor cells. These are the cells that undergo mitosis. These are the cells that actually are the stem cells of your bone. So that is the last thing I think that we covered last time. So I'm going to continue with several of the other cells. The next kind of cell is an osteoblast. Okay, osteoblasts are formed from the osteoprogenitor cells. They differentiate from the osteoprogenitor cells. Okay, so osteoblasts come from the osteoprogenitor cells. I'm going to type in a question here. When a cell is created from another cell through differentiation, what does that tell you? What does that tell you What does that tell you about the cell's gene expression? When a cell is created from another cell through differentiation, what does that tell you about the cell's gene expression? I don't expect you to be geneticists and be experts on this, but there's just a simple principle here I'm wanting you to appreciate. Any thoughts on that? You can unmute and answer or type an answer into the chat window. Okay, so I'm getting a lot of silence here. What I'm wanting you to appreciate is that when a cell is created through differentiation, what that's immediately telling you is that, okay, Pam says we're building cells, that's true, okay. What this is telling you is that the gene expression of the cell being created is different from the gene of the cell that is the source of the creation. There's a change in gene expression. That's what I want you to appreciate, is that differentiation can only occur when there is a change in gene expression. Right? If you think about it, if we have one kind of cell called an osteoprogenitor cell and a second different kind of cell called an osteoblast, well, there has to be something that makes the two cells different. What is it that makes the two cells different? That thing that makes them different is an alteration in the cell's usage of its genes. There's a change in the gene expression between the two cells. Okay, so osteoblasts are referred to as bone building cells. These are bone building cells. And what the osteoblasts do is they manufacture and secrete collagen and other materials needed to make the extracellular matrix of bone. Okay, they manufacture and secrete collagen and other materials needed to make the extracellular matrix of bone. Okay. In addition to that, the osteoblasts initiate what's referred to as calcification of the bone. Calcification basically means that the minerals of the extracellular matrix are hardening. So osteoblasts start the calcification process, and this actually hardens the bones. Okay. All right. So again, reminder, if you have questions or comments, feel free to type them into the chat window or unmute your microphones. Okay, next, cell number 3. Cell number 3 are osteocytes. Okay, osteocytes are mature bone cells. Osteocytes differentiate from osteoblasts. Okay. So if we think back, osteoblasts develop from osteoprogenitor cells. Osteocytes develop from osteoblasts. If we think about some analogies, you know, we have examples in Mother Nature where one thing transforms into another thing. And I guess the easiest example is when a caterpillar changes into a butterfly. Or if we think of some of the horror movies that you folks like to watch around Halloween, where we think about a werewolf and the man transforms or metamorphosizes into a werewolf. That kind of changing from the caterpillar to the butterfly, from the man into the werewolf, that would be sort of the equivalent of differentiation. Okay. The osteocytes are the mature bone cells. And as such, that means that these are the cells that are responsible for the daily metabolic activities of the bone itself. Osteocytes are responsible for the daily metabolic activities of the bone. I kind of think of the osteocytes as mom and dad, right? Mom and dad make sure everything is taken care of, right? That the bills are paid so the electricity stays on. There's food in the refrigerator so everybody has food to eat. You know, these are the mom and dad cells of each bone of your skeleton. Finally, another kind of cell is the osteoclasts. Okay, if you look at the osteoclasts on figure 6.2, page 174, you can see they look kind of weird. I mean, one of the noticeable things is that there's multiple nuclei inside these cells. Okay, so osteoclasts are primarily responsible for bone remodeling. Okay. So, you know, the idea here would be that as your lifestyle changes, as you go from being a couch potato to working out in the gym, you're placing the bones of your skeleton under different stresses. And because of this difference in stresses to the bone, the composition of the bone has to change to make it stronger. Okay. All right. So let me ask you at this time, since our lives have been disrupted by the coronavirus and we are no longer traveling to school a couple times a week to take classes, that means we are a little bit more sedentary than we would otherwise be. What effect do you think that will have on the composition of your bone? Since we're not out moving around as much, we're not traveling to school, we're not walking around to get to classes, if we don't make up for that loss of activity at home, what's that going to do to our bone composition?
Probably soften it.
Exactly, Brendan. You can expect that if you take this opportunity to be away from school and you don't get outside and exercise, you don't walk around, and you become more sedentary, you can expect that your bones will actually weaken a little bit. Their structure will soften. Okay. All right, so let me point out a couple features of the osteoclasts. Osteoclasts are very large cells. And the reason they're very large cells is because these are cells that form from the fusion of very tiny cells in your body called monocytes. So osteoclasts are very large cells because they are the result of many monocyte cells fusing together. Okay. It's because of these monocytes, because of these monocytes fusing together, since each monocyte has its own nucleus, when they fuse together, that creates a very large cell, a megacell, that is multinucleated. Okay? Because each monocyte has its own nucleus, the resulting osteoclast is a multinucleated cell. Okay.
Dr. Allen,
Yes.
when you say that the bones get softer, does that mean like your body starts to feel like it's stiff?
Well, when your body starts to feel stiff, that can be from a combination of things. Yes, you can feel stiff because you're not moving the bones as much as you used to. That can happen, but don't forget, you're also going to get a feeling of stiffness from the muscles. So there's a combination of factors at play when you kind of feel stiff.
Okay.
Other questions? Okay. All right. So the ability of the osteoclasts to remodel the bone is due to the fact that osteoclasts have a lot of lysosomes in them. And you recall from your study of chapter 3 in the course that lysosomes are the organelles which are the remodeling organelles. They are the recycling organelles. Okay. The ability of osteoclasts to remodel bone is achieved from all the lysosomes inside the cell. Okay. All right, gang. One other thing I'll mention, I think this was probably in one of your lab homework assignments a while back. In fact, I'm 99% sure I remember this being a sort of a question or a picture in your lab homework. Remember that I'm pretty sure in your lab homework you had two images, one of normal bone and one of osteoporotic bone, if you remember that. An osteoporotic bone kind of looked like Swiss cheese. It had a lot more holes in it. Well, osteoporosis is often, what medical scientists know about osteoporosis is that osteoporosis is often caused by abnormal osteoclast activity. So the osteoclasts are actually behaving too aggressively to remodel the bone, and that leads to osteoporosis. Now, why they start behaving that way in the first place is still a bit of a mystery. Osteoporosis is thought to be due to abnormal osteoclast activity. Okay, gang. All right, folks, that wraps up our coverage of the bone cells. Do you have any questions at this time? Shaka, Could you please restate your question? What do you mean from lack of vitamin D? Are you asking me about osteoporosis, or what are you asking? Okay, right. Okay. Vitamin D can be one of the triggers that a lack of vitamin D can be one of the triggers that causes the abnormal osteoclast activity. That is something we do know. Anything else? Okay, gang. All right. Let's move on. The next topic I want to talk about is highlighting some of the features of compact and spongy bone. And for that, probably it's best for you to be looking at figure 6.3, page 176. Okay. Features of compact and spongy bone. So I'll highlight figure 6.3. And we'll talk about compact bone first. Okay, so let me just highlight some features that I would want you to be aware of, sort of some vocab that would be important potential for your second exam coming up in several weeks, things that you definitely want to pay attention to. Okay, so compact bone is the strongest form of bone in your body. It is stronger than the spongy bone, okay? Compact bone is the strongest form of bone in the body. You know, if you were to look at a Halloween skeleton, the surface of the bone that you could look at with your eyes, the surface of the bone that you saw in lab when you were studying it, would be compact bone. But if we're being extremely precise, the surface of the bone of itself is actually wrapped in a very special membrane called the periosteum, okay? Excuse me, the surface of bone is wrapped by the periosteum membrane. Okay. And again, you can see that on figure 6.3. If you look along the right side of the image, make sure you put your eyeball on the periosteum, okay? Now, question to you. What structure or membrane, if you will, I'm kind of being a little bit more precise in my question. What structure or membrane does the periosteum differentiate from? Can anybody answer that? What structure or membrane does the periosteum differentiate from? Where does it come from? I feel like I'm on Jeopardy. Anybody?
Compact bone?
Okay, thank you, Brendan. No, that's not what I'm fishing for, but I appreciate you trying. Anyone else? Okay. All right. Well, gang, let me ask you this question first. When your bones are beginning to form inside the womb before you were born, what are the bones of your skeleton made out of?
Cartilage?
Cartilage. That's the key. So the answer is not cartilage, but that's a hint to what the answer is. The periosteum develops from a membrane that's around cartilage because your bones start out as cartilage, not as bone. In other words, your bones start out made of cartilage rather than osseous tissue. So the answer to this question is the membrane that we find around cartilage, and that's called the perichondrium. Perichondrium. Maybe something that you folks want to look up during your study time, exactly what is the perichondrium. Perichondrium, okay? Let me just highlight this. The perichondrium is a membrane that covers most cartilages. Remember, your bones start out as cartilage. Okay. All right, let's continue here, folks. Number 3. Compact bone that you look at on page 176 is made of these repeating cylindrical structures called osteons. So another way of saying that is that compact bone is made of the structural building block we call an osteon. Okay, so make sure you know what osteons are. Okay. If we look at the structure of the osteon, let me just point out a few things. Okay, let me point out a few things here. If you look at the osteon structure, let's see here. Trying to see what might be the best picture for you. I guess we can stay on page 176 here. Okay. What you'll notice is that each osteon is made of these, what are called concentric, going around in laps, in overlapping rings, kind of like the rings inside a tree, made of these rings called lamellae. Okay. And these lamellae form around an open cavity called the central canal. Made of concentric rings called lamellae that form around the central canal. And of course, the central canal is where the blood vessels run through and go into the deep structure of the bone itself. So those are the blood vessels that run through the central canal. Okay. All right. If you look very carefully, and you can probably see this in picture C at the bottom right of page 176, here they have kind of a similar structure in trabeculae that doesn't have the central canal, but the same idea is going to be true for the osteon structure. And do you notice that within each osteon, sort of in between the lamellae, there's these spaces called lacuna. Okay, do you see the lacuna? Okay, note the lacuna. These are pockets of space in between the concentric lamellae. What's important about the lacuna is that these pockets of space provide an area for bone cells, most notably the osteocytes, to sit in. Okay, so within the lacuna, you find bone cells like the osteocytes. And finally, the last feature here that I would ask you to pay attention to is the canaliculi. I know that's a weird sounding word, canaliculi. Take a look at that. You can see canaliculi in the magnified region of picture A, right? You see the osteocyte, you see the lacuna that it's in, and then you see the canaliculi. The canaliculi are actually channels that allow for nutrients to move into and out of the cells in the lacuna. Okay, note the canaliculi. Very strange word. These are channels that allow for nutrients to move into the bone cells and waste material to leave the bone cells and be removed from the body. Okay. Folks, do you have any questions about the compact bone anatomy that you see on page 176? Okay, not seeing any questions. Let's move on to a couple statements about the spongy bone. Let me see here. After this, we're going to start talking about physiology, so hopefully it'll get a little bit more interesting. I know this is kind of cut and dry stuff, but it is some things we do need to be sure are in your notes. Okay, so let's take a look at the spongy bone. You see on page 176, you notice that on picture A in the middle of the page, the spongy bone is the bracketed area of tissue along the left side of that picture. And really what that's telling you is that the spongy bone is found in the interior of the bone. The spongy bone is deep. It is deep to the compact bone. Okay. Okay. Spongy bone is deep to the compact bone, being located in the interior of each bone. Spongy bone is also known by two other terms. It's also known as trabecular bone or cancellous bone. Trabecular bone or cancellous bone. These are all synonyms. Spongy bone, trabecular bone, cancellous bone mean the same thing. These are all synonyms. Okay. So the most notable thing to point out is that when you look at the spongy bone, you don't really see the typical osteon structure that you see in the compact bone. Most notably, what you see are these unusually shaped spikes or tubes, girders, if you will, that are actually called trabeculae. And you can see that highlighted on picture B at the lower left corner of page 176. Okay. Spongy bone is made of trabeculae. And the term trabeculae literally means little beam. Okay, that's what the word means. Trabeculae means little bean. Okay. All right. Now, one of the things I want to point out at this time is that you notice that the compact bone is very uniform and consistent in its appearance, but spongy bone has these tubes, and in between the tubes, in between the trabeculae, there's simply a lot of open space. Okay, so the open space between trabeculae serves a couple purposes. First, the open space allows the fact that there is open space in the spongy bone allows your bones to be lighter than they otherwise would be. So the open space allows for bones to be lighter than they otherwise would be. And that open space can often be used to store other material. And what I'm hinting at is that the open space in between the trabeculae can be used to store either red or yellow bone marrow. The open space is used to store either yellow or red bone marrow. Okay. As a rule of thumb, okay, so that means there's going to be some exceptions, but as a rule of thumb, long bones, okay, long bones of the body, like the femur, for example, long bones, the spongy bone portion of the long bones is going to be used to store yellow bone marrow. Long bones have yellow bone marrow in their spongy bone. And short, stubby bones, irregular bones like your vertebrae, those will contain red bone marrow. Okay. Okay. Folks, any questions at this time? All right. Okay, folks, so let's switch gears at this point and start talking about some physiology. So what I'm going to do next is start talking to you about topics that kind of merge chapter 5 and chapter 6. If we think about it, chapter 5 was the integumentary system, and I spent most of my time honestly talking about the skin. So chapter 5 is sort of about the skin, and chapter 6 is about the bones. Well, what's the commonality here? The commonality is that your skin plays a role in manufacturing vitamin D. Vitamin D is important for your body to absorb calcium, and calcium, when you have too much of it, is actually stored in the bone. So that's the connecting point between the skin and the skeleton, is the vitamin D production that starts with the skin and the calcium absorption into the extracellular matrix of the bone. So these two topics I'm going to bridge together in my next conversation with you. Okay, so we're going to shift to physiology. And I'm going to bridge chapter 5, vitamin D formation, to calcium absorption, to chapter 6, calcium absorption in bone. Okay, so we're going to look at topics that bridge these two chapters together. And so I'm going to highlight 2 pages for you. Pages of reference are going to be pages 159 and 160 in chapter 5, because this talks about vitamin D synthesis. And also pages, one moment please, pages 188 and 189 in chapter 6, where we talk about calcium homeostasis in the bone. Okay, folks, I do not mind telling you that vitamin D synthesis and calcium homeostasis in the bone and blood are going to be a major essay on your next exam. You want to understand vitamin D synthesis and calcium homeostasis in the body as it refers to the bones. This will be an essay on exam 2 coming up in about 3 weeks. Okay, so let me give you some background here. Okay, first off, let me give you some background about vitamin D. All right. So, where to begin? Okay, let's start by defining what a vitamin is. A vitamin is a substance that the body needs but cannot make for itself. So, this presents a problem because vitamin D can be made by the body, which means vitamin D does not fit the definition for a vitamin, which is why vitamin D is actually a misnomer. It is mislabeled. Vitamin D is technically not a vitamin because the body can make it. Technically speaking, vitamin D is not a vitamin. It was mislabeled as a vitamin years ago, and that mislabel caught hold. As we've seen in other cases in the course, sometimes there's kind of silly information that gets ingrained in a body of knowledge from a historical perspective because of some mistake or error that was made decades ago, and we simply haven't corrected it. We've learned to accept it as an oddity that you simply have to remember. So a vitamin is a substance that the body needs but cannot make for itself. Vitamin D can be made by the body, so technically it's not a vitamin, even though we call it vitamin D. You see how ridiculous this is? But this is how this works. So vitamin D is technically not a vitamin. If you're familiar with the chemical makeup of vitamin D, you would know that vitamin D is technically a steroid hormone. Okay. All right, so vitamin D, we're going to call vitamin D, but we know that technically it's not a vitamin, it's actually a steroid hormone. I know it's weird, folks, but it's one of those gotchas that I have to point out because you need to be aware of it. Next, when you say the phrase vitamin D, you are not referring to a single specific molecule. You are referring to a group or family of molecules. Okay, the phrase vitamin D does not refer to a single molecule, but to a group of molecules that have some similarity in their chemical structure. Okay, all right, let me see here. Depending on, maybe you've had some nutrition classes or things like that. Let me say this up here in part B. When you say vitamin D, you're referring to a group or family of molecules. There's actually 5 members to this group. 5 different molecules belong to the vitamin D family. Okay, we're not going to list all of them out because I don't need to for our topic of conversation. Okay, but as an example here, okay, you may have heard of vitamin D3. Vitamin D3, okay? The chemical name for vitamin D3 is cholecalciferol. I'll spell that for you. cholecalciferol. Right? Simple. Cholecalciferol. That's vitamin D3. Vitamin D3, cholecalciferol, is the chemical precursor to the bioactive form of vitamin D that's responsible for calcium absorption. Okay, so before I get too far ahead of myself here, cholecalciferol is the precursor to the version of vitamin D used by the body to absorb calcium. Okay, vitamin D3 is called cholecalciferol, that's its chemical name, and cholecalciferol is the precursor to the version of vitamin D used by the body to absorb calcium. Okay, now, because we're going to be talking about calcium and its relationship to bones, I need to tell you what the technical version of that form of vitamin D is. So, excuse me, the version of vitamin D that allows you to absorb calcium is called calcitriol. It's called calcitriol.
Dr. Allen, is jaundice a form of vitamin D deficiency?
Not typically, no. Jaundice is typically a different blood chemical. Shock, I see your comment that you give out vitamin D3 to the old folks. Yes, that's very commonly done. So you give them the precursor that their body then modifies into calcitriol. That's fantastic. Okay. All right. So let me give a quick question to be sure that you're following along. True or false? Calcitriol is the precursor to vitamin D3. Is that true or false?
False.
It is false. Correct. It's the other way around. Vitamin D3 is the precursor to calcitriol. All right, just trying to be sure that you're with me, gang. All right, so let's continue here. Calcitriol Okay, so I'm Roman numeral letter I under letter D here. Calcitriol is known by the chemical name of 1,25 hyphen dihydroxyvitamin D. 1,25 dihydroxyvitamin D. Okay, that is the chemical name for calcitriol. Calcitriol is the bioactive version of vitamin D that allows you to absorb calcium. Okay, do you have any questions so far? Because I know there's a lot of background here to get used to things. I'm not going to try to make you a chemist on vitamin D, but I certainly want you to appreciate that vitamin D refers to a family of molecules, and that the version of vitamin D that allows you to absorb calcium is calcitriol. That's very important that you appreciate that.
What happens if your body doesn't have that?
If their body doesn't have that, or it can't make it for itself, then you have problems absorbing calcium. And if you have problems absorbing calcium, that throws off many different processes in the body. If your calcium levels are abnormally low, your muscles won't contract properly, your neurons cannot release neurotransmitter properly, some glands will not be able to release hormones properly. It has a wide range of damaging effects to your body.
And what exactly do you mean by precursor?
Precursor is the thing that comes before it. So in other words, okay, so what do I mean by precursor? Okay, let me write that question down. Without going into the chemistry of vitamin D, we have to think about a biochemical pathway. Okay, so in a biochemical pathway, you will have substance A that is used to make substance B, which is used to make substance C, and you can see I could continue this on, used to make substance D. So a precursor for substance C would be substance B. Substance B comes before substance C in the biochemical pathway. Does that make sense?
Yes.
Okay. So, okay, I saw your question there, Shaka. Does precursor mean that it is absorbed first? Not necessarily, but it does come first in the biochemical pathway. Okay. All right. So let's continue here, folks. So that's some background about vitamin D. Keep that in your memory banks. Now I'm going to give you a few pieces of background information about calcium and the bones. Okay, and then we're going to tie it all together. Okay, so number 2 is going to be calcium background, calcium and bones. All right. First off, you should know that your bone tissue is the body's major reservoir to store calcium. It's your bones hold 99% of the total body calcium in your body. All right. So as I alluded to in my answer, I think to Suzette's question, in particular, nerve and muscle cells require calcium to function properly. So if we don't have a good supply of calcium in the body, things don't go well. Okay. Now, the bone is the major reservoir for storing calcium, right? Please understand that, right? The bone is a reservoir for storing calcium. But there's storing calcium, and then there's allowing calcium out into the body to be used for some physiological purpose, such as muscle contraction or neurotransmitter release in the brain. So the calcium, when it's not being stored in the bone, it has to be used by the body. And in such a case, that means the calcium has to be distributed through the bloodstream. So the proper level of blood plasma, the proper level of calcium in the blood plasma is about 9 to 11 milligrams of calcium per 100 milliliters of plasma. When calcium is being used and distributed by the bloodstream, the homeostatically normal range of blood calcium is 9 to 11 milligrams of calcium per 100 milliliters of plasma. Okay, 9 to 11 milligrams per 100 milliliters. Okay. Letter D. We talked about homeostasis in chapter 1 of the course, and we talked about positive and negative feedback systems that monitor and maintain homeostasis. I hope you remember that. And what I want you to appreciate is that while bone is the reservoir for storing calcium, blood is the tissue that's used to distribute calcium, and the physiologically healthy homeostatic level of calcium is actually measured in the blood, not the bone. The blood calcium is where homeostasis is monitored.
Dr. Allen, I have a question. If your body produces too much calcium, what happens to your bones?
Your body cannot make calcium, but it can absorb calcium from your diet. So if you absorb too much calcium, now that would be really hard to do because your body has a tremendous capacity to store excess calcium in the bones. But if you got to a point that you couldn't hold any more calcium in the bone, then calcium would start to come out in your urine. Okay? Homeostasis of calcium is measured and monitored in the bloodstream. Okay, folks, does it make point the distinction that I'm trying to give you that that calcium levels in the body are homeostatically measured and monitored in the bloodstream, and excess quantities of calcium are stored in the bone? Does that make sense? I hope so. If it doesn't make sense, please stop me. Please ask a question. All right. Last thing that I'll mention here, and this involves some new terms. Okay. Okay. When it comes to calcium storage in the bone, okay, you can think of your bone as a calcium battery. You know, if we think about what a battery is, well, you think about a double A battery that you buy at the store. A double A battery is this cylindrical tube-looking structure that stores chemical energy that can be converted into electrical energy in our electronic gadgets. Well, bone is kind of a battery that can store calcium in a similar analogous fashion. So when blood calcium is too high, excess calcium is deposited into bone. And we'll tell you about how that happens in just a moment. But what I want you to highlight is the word deposited, or more formally, deposition. Okay, when you store excess calcium in the bone, that's referred to as deposition. You are making a deposit. If you have too much money at your house, which I know is hard to imagine, you would take the money and deposit it at the bank. You would take the money and deposit it at the bank. Okay? When blood calcium is too low, then you need to go to the bank and make a withdrawal of the money. You need to go to the bone and withdraw the calcium. The proper term for withdrawing calcium from the bone is called resorption. When blood calcium is too low, you need to withdraw calcium from the bone. This is called resorption. Folks, be very, very careful that you understand deposition and resorption. It's something that I could tickle you with on a future exam. Okay. All right, gang, before I go any further, any questions? All right. So now let's take this background information that we have, and let's try to connect the dots of the physiology of what's happening here. Okay, so again, we're going to try to connect vitamin D production to the absorption of calcium into the bloodstream. Okay. All right. So this will be an overview of vitamin D synthesis, and calcium absorption into blood, into the bloodstream. All right. If I were with you in class, I would probably draw a flow chart on the board, but that's kind of difficult to do here on the computer. So I will just talk in bullet points or steps to try to make it clear. Okay, so the process of making vitamin D starts in your skin. It does not finish in the skin. You do not make bioactive vitamin D in the skin. What you do is start making the precursors necessary to form bioactive vitamin D in the body. So the, excuse me here, the production of bioactive vitamin D begins in the skin. Okay, please appreciate that phrasing. It begins in the skin. Okay, I'm not telling you that bioactive vitamin D is made in the skin. It is not. the process of making bioactive vitamin D, calcitriol, starts in the skin, but it doesn't finish in the skin. Okay, so you know, you're all experts from chapter 5 about your skin, right? The epidermis and the dermis, and you know about all these varieties of cells that make up the various layers, particularly of the epidermis. Okay, so you know that your skin is made of cells, and the outermost layer is actually made of dead cells, dead keratinocytes. But suffice it to say that in the cells at the surface of your skin that are still alive, those cells have a plasma membrane. And that plasma membrane, which you remember, is made of a phospholipid bilayer. If you remember from chapter 3, the phospholipid bilayer of the plasma membrane doesn't just have phospholipids in it, it also has other molecules that are stuck in the phospholipid bilayer. And the important part for our conversation right now is that in the plasma membrane of your skin cells, there's this chemical called 7-dehydrocholesterol. Within the plasma membrane of skin cells, there is a chemical called 7-dehydrocholesterol. Okay? This 7-dehydrocholesterol is stored in an inactive state, an inactive condition, if you will. Okay? So we have 7-dehydrocholesterol, which is inactive. And here's the deal, gang. When sunlight hits the surface of your skin, it activates this molecule. It turns it on. Now this, we're not going to get into the heavy chemistry of it because, none of us really have the background for that. But do you know what I mean? Do you have any old family photos at the house? Not on your tablet, not on your cell phone or computer. I'm talking an actual printed photograph. Do you have any family photos, actual true photographs that are printed at the house that are old enough that when you look at them, you can tell through the passage of time and exposure to sunlight that the images have faded a little bit? Does this make sense?
Yes.
What I'm trying to suggest to you is that sunlight can actually do things to material. And what's happening here is that when sunlight hits the surface of your skin, it actually strikes this inactive molecule and very slightly changes its chemical structure into a form that makes it activated. Okay? So the sunlight hits this molecule and kind of turns it on.
Dr. Allen, when you say the vitamin D is not made in the skin, when someone has a vitamin D deficiency, doesn't that have to do with your epithelial like skin as well?
Well, it could be. For example, some people, due to lifestyle choices, don't go outside a lot into the sun, right? We have people that are afraid because of skin cancer and things. They don't go out to get enough sun exposure. That happens, and it can make them vitamin D deficient. We have people these days that lather on so much sunscreen to protect themselves from skin cancer that when they go out, the sunshine can't do what it's supposed to do, which is start the process of making vitamin D. That can definitely happen. Okay? Was there another aspect to your question, Suzette?
No.
Okay, thank you.
Hmm?
Okay, so we have this molecule in the plasma membrane of your skin cells getting activated when sunlight hits them. Okay? when this molecule is activated, the activated molecule moves and enters the bloodstream. Okay, so the activated molecule enters the bloodstream. Okay, this activated molecule is sent through the bloodstream to the liver. Activated 7-dehydrocholesterol is delivered to the liver. Okay? Now, we're not getting into the biochemistry of things because it's too much for our course. But gang, here's the deal. The activated 7-dehydrocholesterol in the bloodstream is delivered to the liver. In the liver, liver cells take the activated 7-dehydrocholesterol, and enzymes that are made in liver cells convert it to another substance. Okay? Liver cells use the activated, so you have 7-dehydrocholesterol to make another substance. Okay? This new substance made in the liver is put back into the bloodstream for delivery to the kidneys. This new substance enters the bloodstream and is delivered to the kidneys. You never knew things were so complicated, did you? Okay, this new substance that was made by the liver cells is delivered to the kidneys. In the kidneys, the cells of the kidneys use their own enzymes to take the new substance that was made by the liver and manufacture the bioactive form of vitamin D needed to absorb calcium, which you know as calcitriol. In the kidneys, enzymes modify the new substance from the liver into bioactive vitamin D, also known as calcitriol. So if you don't have, I mean, you can appreciate that we have a whole series of events where one thing has to happen, then the next thing has to happen, then the next thing has to happen. Any one of these steps could have a problem. There could be a genetic defect in the enzymes of the liver. There could be a genetic defect in the enzymes of the kidneys. So there could be a variety of ways that you could block the actual production of calcitriol, which would then prevent your body from properly absorbing calcium. Okay? So, you know, low calcium in the body could be caused by a variety of different genetic malfunctions. Okay, getting back to our story, and I'm watching our time. I know we're almost out of time. In the kidneys, enzymes modify the new substance from the liver into bioactive vitamin D, also known as calcitriol. Okay? Let me finish this statement, then I'll wrap up for our day here. Okay? Calcitriol is made in the kidneys. Okay? Calcitriol is made in the kidneys. Once it's finished being made, calcitriol enters the bloodstream. And delivered to what structure? You tell me, folks, what structure of your body, which organ of your body, what tissue, what structure of the body is responsible for absorbing calcium? What region of your body, what piece of anatomy absorbs calcium? Please type it into the chat window if you know. Jennifer, I see your question. I'll address that in just a moment. Okay, so it looks like nobody knows. All right, folks, your small intestine. Your small intestine is responsible for absorbing the nutrients from your food and drink, okay? So calcitriol enters the bloodstream and is delivered to the small intestine, which is responsible for absorbing calcium and other nutrients in the body. Okay. I'm not finished with this story, but at least I got the first part done. So we're going to wrap up at this time because it is 9:17 by my clock. Jennifer, you had a question, why does the lack of vitamin D cause depression? That's a hard one to truly answer for you, but let me remind you of this. Vitamin D vitamin D allows you to absorb calcium. If you're not absorbing calcium properly, then your nervous system tissue, the cells, the neurons can't function properly. And obviously, if your brain cells aren't functioning properly, that could lead to depression. A second thing to keep in mind, Jennifer, is that vitamin D is also, various members of the vitamin D family are also important in maintaining the health of your immune system. And your immune system, believe it or not, actually talks to your nervous system. So if there's some kind of disturbing message coming from the immune system to the nervous system, that can promote depression as well. The ultimate final specific answer, though, Jennifer, to your question is nobody quite knows. All right. Do any of you have any other questions before we continue here? Well, actually, before we sign off. Okay, gang, I will be sending out another email today with the recording to this lecture. I'm going to be back online with you in about 15 minutes for anybody that wants to have office hours. If anybody would like to get the answers to the homework that was assigned as due this week, I can do that. If you have other things you want to chat about, I'll be back online with you at this location, at this Zoom meeting in about 15 minutes. Until that time, be safe. Have a good weekend. Please try to create your free class marker account and take the practice quiz for me. Okay? I will see some of you in 15 minutes. The others, have an enjoyable weekend. Okay, welcome back, everyone. Hope you're doing well. I had a chance to get some refreshment or something. So as I've been saying and will continue to say, you know, our time right now is just meant to be supportive of you in terms of if you have questions for lecture or lab. It really can't be a complete substitute for lab because, you know, we're not together in any way. But one thing that I can do is I can give you the answers for your homework that would technically be due today if we were in fact together. So I don't want to make the assumption that you want the answers to the questions. So please type yes into the chat window if you would like me to give you the answers to the reviewing your knowledge and using your knowledge portions of the homework. Okay, I'm getting some yeses, so we'll do that. All right. Okay, so let's start with lab exercise 11. Okay, lab exercise 11. And we're going to be using reviewing your knowledge. Okay, so that would be from your lab manual, that would be page 171. I'll try to go reasonably slow and I will pause and ask if you need me to repeat anything. Okay, exercise 11, letter A, the structural and functional classification of joints. Letter A, number 1 is a diarthrosis. 2 is a synarthrosis. 3 is an amphi, that's A-M-P-H, amphiarthrosis. 4 is synovial. 5, cartilaginous. 6, synovial. And 7, fibrous. If you need me to repeat any of that, please type in your request in the chat window. Okay, looks like everybody's all right. Let's go to letter B, the structure of synovial joints. Number 1, hyaline. 2, synovial. 3 is hyaline cartilage, which is sometimes simply referred to as articular cartilage. 4 is bursa. 5 is the synovial membrane. Do you need any of that repeated? Number 1 is hyaline. Number 1's hyaline. Number 2 is synovial. Okay, moving on to section C on page 172. Types of synovial joints. Okay, hold on a second, let me backtrack. For section B, number 2 is synovial and number 3 is hyaline cartilage. Okay, moving to section C, types of synovial joints, page 172. Number 1 is a pivot joint. 2 is a ball and socket joint. 3 is a hinge, H-I-N-G-E, hinge joint. Number 4 is a planar or sometimes called gliding joint, planar or gliding. 5 is saddle. 6 is condyloid. Do you need any of that repeated? Okay, letter D, movement at the synovial joints. Number 1 is adduction. That would be A-D-D, adduction. 2, extension. 3, depression. 4, supination. 5, plantar flexion. 6 is flexion. 7, abduction. That's A-B-D, abduction. 8, rotation. 9, elevation. 10, protraction. 11, inversion. Folks, do you need any of those repeated? Okay, let's move to using your knowledge on page 173. Page 173, letter A, the synovial joint anatomy. Letter A, number 1 is articular cartilage. Number 2 is the synovial cavity, which is also sometimes called the glenoid cavity. 3 is the articular capsule, which is sometimes called the fibrous capsule. 4 is articular cartilage, or you may have actually referred to the trochlear notch. Either of those two is okay. For number 4, articular cartilage or trochlear notch would be acceptable. Number 5 is articular capsule or the fibrous capsule. They mean basically the same thing. 6 is the acetabulum. 7 is the synovial cavity. 8 is the greater trochanter of the femur. 9 is the ilium. And 10 is the head of the femur. Do you need any of section A repeated? Number 3 is the articular capsule. You may have also said fibrous capsule. So articular or fibrous capsule. Okay, let's move to section B on page 174. The synovial joint movements. Number 11 is flex. 12 is dorsiflex. 13 is extend. 14 is extend. 15 is plantar flex. Folks, if you're confused by any of these, we are going to be talking about them in lecture next week. Do you need any of section B repeated? Okay, gang, let's move to lab exercise 6. That was the second exercise that's technically due today. Lab exercise 6 was your histology activity. And so let's go to page 77 of your lab manual. Bear with me a moment while I find my notes. Okay, so exercise 6, letter A, the primary tissue structure and function. Letter A, number 1 is nervous tissue. 2 is muscle. 3 is connective. 4 is epithelial. 5, 6, and 7 are epithelial, muscle, and nervous. Questions 8, 9, and 10 are epithelial, muscle, and nervous. Number 11, connective tissue. 12, connective. 13, epithelial. 14, nervous. 15, muscle. Do you need any of section A repeated? Okay, let's go to section B on page 78, where we're talking about the types of epithelial tissues. Letter B, number 1. Pam, are you asking me for number 3 and 12 again? Okay, folks, let me back up for section A. Section A, number 3 is connective tissue. Number 12 is connective tissue. Okay, section B, page 78. Number 1, stratified squamous epithelium. Number 2, simple squamous epithelium. 3 is simple cuboidal epithelium. 4, pseudostratified ciliated columnar epithelium. 5, simple squamous epithelium. 6, simple columnar epithelium. 7, transitional epithelium. Okay, so for section B, do you need anything repeated? Okay, let's move to section C, the connective tissue. Section C, number 1. 1 is elastic tissue. 2 is dense regular tissue. 3 is hyaline cartilage. 4 is areolar tissue. 5 is elastic cartilage. 6 is spongy bone, which you know is also called trabecular bone. 7 is reticular tissue. 8 is dense irregular tissue. 9 is blood. 10 is adipose. 11 is compact bone, which is also called cortical bone. 12 is fibrocartilage. Numbers 13 through 18, you can see there's a bracket around them. 13 through 18 are the following answers: areolar, reticular, adipose, dense regular, dense irregular, and elastic. Excuse me. Numbers 19 and excuse me. 19 and 20 are compact bone and spongy bone. 21 through 23, which are, again have a bracket there. 21 through 23 are hyaline cartilage, elastic cartilage, and fibrocartilage. 24 is blood. Folks, do you need anything from section C again? Okay. Let's go to section D for the muscle and nervous tissue. Letter D, number 1 is smooth muscle. 2 is skeletal muscle. 3 is cardiac muscle. 4 is nervous tissue. 5 is smooth muscle. And 6 is smooth muscle. Do you need any of section D repeated? Okay. Then we're going to start section E on page 80 and 81, where you had all these beautiful pictures that you had to try to identify. Let's see how well you did. Letter E, number 1. For number 1, you're looking at pseudostratified ciliated columnar epithelium. Pseudostratified ciliated columnar epithelium. Number 2 is stratified squamous epithelium. 3 is transitional epithelium. 4 is simple columnar epithelium. 5 is simple cuboidal epithelium. 6 is simple squamous epithelium. 7 is dense regular connective tissue. 8 is compact bone. 9 is elastic connective tissue. 10 is areolar connective tissue. 11 is hyaline cartilage. 12 is adipose tissue. 13 is blood. 14 is dense irregular connective tissue. 15 is reticular connective tissue. 16 is elastic cartilage. 17 is spongy or trabecular bone. and 18 is fibrocartilage. Folks, do you need any of section E repeated? Okay, you're doing well then. Let's go to the final section on page 82, letter F, the muscle and nervous tissue identification. Letter F, number 1 is smooth muscle, 2 is nervous tissue, 3 is skeletal muscle, and 4 is cardiac muscle. Okay. Any of that you need repeated? All right, gang, let's go to using your knowledge on page 83. Using your knowledge, page 83. Okay, so letter A was about genetic diseases and tissue function. Okay, I'm seeing a comment from Shane Lee. Shane Lee, you wanted number 4? I'm assuming from section F. Letter F, number 4 was cardiac muscle. Okay, using your knowledge, section A, genetic diseases and tissue. Okay, you were to identify the abnormal protein and state how the abnormal protein affects the function of the tissue. Okay, obviously, some of the wording of this would be unique to how you answered each question, particularly when we're talking about the function of the tissue and how the abnormality impacts the function of that tissue. So don't look for a word-to-word answer. It's okay if your answer is worded different than mine. Think about common ideas. Okay, letter A, number 1. The abnormal protein for cystic fibrosis is called cystic fibrosis transmembrane conductance regulator protein. That's a mouthful. Once again, cystic fibrosis transmembrane conductance regulator protein. This protein is the protein that transports chloride ions across the plasma membrane of the epithelial cells that make up your mucous membranes. Letter B asks you to describe the effect of the abnormal protein. Here's what the abnormal protein does. If you have a defective transporter protein, it decreases secretion of chloride ions and increases the reabsorption of sodium and water across the epithelial cell plasma membrane. The end result in this altered movement of water is you have increased reabsorption of water that makes the mucus thicker. So you get a thick, abnormally thick mucus showing up. This thicker mucus increases the probability of inflammation and increases your risk of infection in the lungs, the pancreas, the GI tract, and in some cases can actually block and clog up some of your exocrine glands so they cannot release material. So the take-home message for part 2 is that when you have a defective transporter protein, you get increased mucus production, a thickening of the mucus as well, which leads to inflammation and more infection in the body. Questions? From Pam, can you say that it affects the fluid secretion in the exocrine glands and the epithelial lining of the respiratory, GI tract, and reproductive tract? Yes, Pam, you can. Okay. Questions 3 and 4 are about Duchenne muscular dystrophy. The abnormal protein for number 3 for Duchenne muscular dystrophy is dystrophin. D-Y-S-T-R-O-P-H-I-N, dystrophin. If you have an abnormal dystrophin protein, we're going to be studying this in the muscle chapter, which is about 2 chapters ahead of where we currently are in lecture. The dystrophin protein is the protein that links a structure in the muscle cell called a myofibril to the interior surface of the muscle cell plasma membrane called the sarcolemma. So the short answer on this is that when you have an abnormal dystrophin protein, the plasma membrane of the muscle cell can actually tear and rip apart. And when that happens, the muscle cell dies. So an abnormal protein causes death of muscle cells. And if you have too many muscle cells dying, obviously the larger muscle organ itself can't work. So if you have too much dysfunction in the heart muscle, you're not going to be able to pump blood through the body. If you have too much dysfunction in your leg muscles, you may not be able to walk and you'll be wheelchair bound. If you have too much dysfunction in the muscles of the respiratory tract, the diaphragm and the intercostal muscles of the rib cage, you may not even be able to breathe properly. Okay, so defective dystrophin leads to death of muscle cells, which then can impair your body's ability to actually breathe, walk, function. Okay, questions? Okay, let's move to letter B, where the question was about nutritional deficiency. Number 5, the nutritional deficiency in this case is vitamin C, not vitamin D, right? We've been talking about vitamin D, which is technically not a vitamin. This is vitamin C as in Charlie. Number 6 asks you to describe the changes to the extracellular matrix and symptoms of having low vitamin C. If you have low vitamin C, you're going to have poor collagen formation, And if you have poor collagen formation, that's going to result in a loosening of your teeth. Can you imagine that you start touching the teeth in your mouth and they wiggle around unnaturally? So you will have loose teeth. Low vitamin C will result in an increase in bleeding. Okay. The blood vessels of the body, when there's less collagen, they don't maintain their natural structure, so you have more internal bleeding. And you will also have very poor wound healing. Like if you were to cut your arm accidentally, collagen is one of the proteins that helps form the scar tissue that helps the wound actually heal. And when you're not making enough collagen, the wounds don't heal properly. Okay, so you have loose teeth, an increase in bleeding, and poor wound healing, all caused by a deficiency in vitamin C. All right, any questions? Okay, question C, section C on page 84. Before I give you the answers to this, let me say that personally I think that this was almost an insane kind of question for a beginner level student, but your book did give it to you. I am not ever going to give you a question like this on the test, so don't worry about it. So if you found the questions for letter C obnoxiously difficult to figure out, don't worry about it. But I will give you the answers. So you're going to be listing the tissues in order from the lumen, which is the hollow area, to the outer surface of the structure. Number 7, we start with the esophagus. For the esophagus, starting at the lumen and progressing outward from the lumen, we have non-keratinized stratified squamous epithelium, followed by areolar connective tissue, which you may have it written down as the lamina propria, followed by smooth muscle, which you may have written down as the muscularis mucosae, followed by areolar connective tissue, skeletal muscle in the upper and middle portions of the esophagus, and smooth muscle tissue in the lower portion of the esophagus. So that's kind of crazy, but it just reveals the complexity of how your internal anatomy is organized. Number 8, the small intestine, starting inside and going out. Number 8, we start with simple columnar epithelium. We go to areolar connective tissue, to smooth muscle tissue, to the duodenal glands, which you may have written down as the submucosa, to smooth muscle tissue, to areolar connective tissue, finishing with simple squamous epithelial tissue. Number 9 is the trachea. Trachea, we start with pseudostratified ciliated columnar epithelium, followed by the lamina propria, followed by areolar connective tissue, followed by the hyaline cartilage, followed by additional areolar connective tissue. And number 10, the ureter. Okay, the ureter, we start with the transitional epithelium, followed by areolar connective tissue, followed by smooth muscle, followed by areolar connective tissue. Okay, so that was kind of insane, and seriously, don't really worry about section C. It's not ever going to show up on a test for you. Okay, gang, do you need any parts of this repeated? Okay, all right, so that's the part of our office hour here that I can provide some immediate feedback to you with. The rest of the time is for you. If you have questions about the course, about content, about what's happening at HAC, about coronavirus, if you have any thoughts or questions, now's your time. Go ahead and, type something into the chat window or unmute your microphone and go ahead and talk. Feel comfortable to do that. The time is yours. Does zinc sulfate help boost your immune system? There is some evidence to suggest that zinc ions can protect you against cold virus. That doesn't mean it's going to protect you against coronavirus. So the answer to your question is zinc sulfate may help with cold virus, but I'm not aware of anything saying it helps with coronavirus, if that's what you're asking about. Does it hurt? Well, probably not. I mean, it's being sold as an over-the-counter medication, and it's been sold that way for years without any considerable harm to the public, so it's been allowed to stay on the market. So, you could probably take it without hurting yourself, but there's not any strong evidence that it's going to help you with coronavirus. Any tips on studying on identifying tissues? Well, Shaka, first off, let me ask each of you, and I'll type this into the chat window, okay? Did you see my email from Monday's class that included a Dropbox link to the histology packet? Did you see that? Please type yes in if you saw the histology packet. Pam says yes. Okay. Yeah. Okay, Shaka, you didn't see that. I thought as much that you may not have seen that, okay? Go check my email from Monday, because I have a Dropbox link in my email that you can get the histology packet, and you can download it to your own personal computer. So let me show you at this time what that's going to look like. Just bear a moment while I find my file, and I'll bring it up on screen share so you can see it. Okay, so I want to share my screen with you. Hold on. There we go. So this is the first page of the histology packet, which you can download from the Dropbox link from Monday's email. If it doesn't work for you, if there's another problem, please let me know. But you can go to my Dropbox, because I'm giving each of you permission to do that. You can get this file and, you know, download it to your computer. And then the idea here is that every page is going to have a different tissue picture on it. And I'm going to highlight various features of the tissue with brackets and arrows and boxes. And over the next week, I would like you to do your very best to identify everything that has a bracket, an arrow, and a box, and write that down here in the grid. Over on the other side is some space that you can write notes about the function of things and the purpose of things. You're not required to do that, and I will not be asking you about the function of anything on the lab exam. I will only be asking you about identification of things. But do your best to identify as much of the items in this packet as you possibly can. So let me start you off with something kind of simple here. And remember, chapter 4 in your textbook is your histology chapter, and that's going to be a very good resource for you when you look at these things, is chapter 4. But as an example, since we've been talking about it in lecture today, let me bring the chat window back up so I can see it. Okay, so folks, can you tell me what kind of tissue is shown in bracket A? What is being shown in bracket A? What kind of tissue? Type in the answer into the chat window if you know it. Because it was talked about in today's lecture. Have any guesses? All right, well, that's going to be part of your study time. Yes, Pam, this is compact bone. Fantastic. Letter A is compact bone. So there you have your answer for A, compact bone. Now we look at B. B is a box around something. What is inside box B? Well, okay, Pam, you say central canal. Okay, the central canal on your screen is right here where I'm circling with my cursor. That's the central canal. So you can see that there's more things in the central canal here. What is the central canal part of? What's the larger thing? Well, the answer is osteon. Letter B is an osteon, right? So letter B is your answer. Osteon is your answer for letter B. Okay. Letter C. What would letter C be? For letter C, I'm trying to highlight these tiny little fibers. Do you see these tiny little fibers that are moving here? These tiny little fibers. What are those tiny little fibers called? Let me ask it this way. Those tiny little fibers are the troughs. What word did we say were the troughs? Well, okay. Okay, thank you, Pam, for answering. No, it's not the lacuna. Okay. I know the bracket looks like it's around the lacuna, but I'm trying to bracket a section of these little fibers. Okay, so C is the canaliculi. C is the canaliculi. Okay. D. D, I'm trying to show you this ring here. This ring, what did we say the rings were? What were the concentric rings called? What were the concentric rings called? lamella. Yes, Pam, those are the lamella. Very good. Letter E is in fact pointing to this black spot there. And so letter E is going to be, for letter E, you could say lacuna, or you could refer to the cell that's in the lacuna. So it would be where the osteocyte is. So for E, I'd accept lacuna or osteocyte, because that's basically true. And then arrow F is trying to point out the central canal itself. Okay, the central canal here, the space here of the central canal. So gals, that's your goal over the next week, is to try to go through as much of this packet as you can, using chapter 4 as your guide to identify as much of this as possible. Next week, during our designated office hour lab support time, I will give you the answers to this packet so you know what they are before your lab exam. Okay? All right. Now, let me say something, because I know I told the other group on Monday. You know, we are in very unusual times right now, and there's stress on everybody. For lab exam 2, you have to know the muscles of the word bank that I gave you, and you have to know histology. But since, you know, we have to be very pragmatic about the time we have available to study. If you have to prioritize what topic you study for your lab exam, muscles versus histology, you should prioritize the muscles. The muscles will be much more important for lab exam 2 than the histology. At this time, I think you're probably going to have about five or six histology questions and about 30 to 35 muscle identification questions on your lab exam. So for this reason, if you have to prioritize where you spend your study time, definitely prioritize with the muscle identification. Okay. All right. Pam, Shanley, are there other things that you have questions about? Other things that I can help you with? Do you have advice for health workers with this virus? Well, nothing that's terribly satisfying, Pam. This is a very infectious virus. So if you're going to be going into a healthcare setting, you really need to be sure that your healthcare provider, your worker, your employer is able to provide you with proper protective equipment. If you go to work and there are no proper face masks for you to wear, or no proper face shields for you to wear, or heaven forbid, not even proper gloves or something for you to wear, then you are definitely putting yourself at risk for catching that virus, which means you're putting your family at risk if you go home. So you're going to have to decide, based on a conversation with your employer, whether they are providing the necessary protective equipment for yourself. If, in fact, you know for certain that you were exposed to the virus, let's say that you were in a hallway and you had your mask off and somebody with known coronavirus comes by and sneezes, if you know you've been exposed, then the difficult but honest best thing to do is to self-quarantine away from your family for 2 weeks. Because this virus takes about 5 to 14 days to produce symptoms in you. So you either have to self-quarantine for 2 weeks, or you have to get a coronavirus test, which might take several days to get a test result if it's even available to you. So there are no easy answers here. I was reading a news report recently that said that if you ask nurses and doctors, will they go help people in times of crisis? Just about 100% of people said, yes, we will help people during an earthquake, during wartime, during other horrible tragedies like this, we will help people. But only about 65 to 70% of doctors and nurses said they'd be willing to go help people during an infectious outbreak of a pathogen like we have right now. Because the reality of it is, you might go to help people, you catch it, and then you might take it home to your family, which would be devastating. So it's a personal decision that you have to make whether you can accept the risks or not, but there certainly are very real risks involved, and it is important that your employer provide necessary protective equipment and support to you. You work in the hospital, Pam, I understand that, absolutely. Okay. The reality of this situation, Pam, is that whether you work in the hospital or not, in the next 6 months of life, just about every American in the country is going to be exposed to this virus in ways that we can't predict. So it's kind of like, do you want to be infected at the hospital, or do you want to be infected a month from now at the grocery store? But at some point you will be exposed to this, because it's hard to combat something that's invisible because it's so tiny. So all of us, myself, my family, we may have already been exposed and I don't know it. We are all going to be exposed to this, and all we can do is hope that once we are exposed, that our bodies don't overreact to it, because that's really what's causing the harm, is when a person's body overreacts to the virus. What else is on your mind? You've been away from mom for 1 week now. Okay. Oh, so your mother has been tested for this? Okay. All right. Yeah. It's a very harsh reality. Things like broken bones and cuts we can deal with, but infectious things like viruses and bacteria are very difficult to deal with. They're just dangerous to everybody, including the healthcare worker. So as hard as it is to stay away from your mom, it is the safest thing for you to do right now. Does your mom have any symptoms? Okay. Do I think the flu vaccine helps? Probably not. Okay. The flu vaccine protects against the flu virus, which is a completely different virus than the coronavirus. There is a tiny bit of scientific evidence to suggest that when you get a vaccine, for one thing, that it helps boost the overall activity of your immune system, so it might be better at fighting other things. But certainly the flu vaccine is not very protective against the coronavirus. So I would expect very, very little protection against the coronavirus from the flu vaccine. Okay, so your mom was coughing and had a fever, but not anymore. Okay. Well, no, I think the best thing for your mom is to rest, because from what I'm reading is that sometimes people have the initial symptoms of coronavirus then they start to feel better, and then it comes back on them very hard with breathing problems, because the virus moves down into your bronchioles around your lungs, makes it difficult for you to breathe properly. So I would encourage your mom, wherever she is, to just rest. Even if she's feeling better, just keep resting for several days. So, okay, she was having some chest pressure yesterday. Yeah, okay. Obviously, is your mom in the hospital right now? She's at home. Yeah, okay. Yeah, I mean, you can self-treat at the house. The warning sign, as I'm sure you know, is if your mom is having trouble breathing, you've got to call the doctor and get her into the hospital, because she may need a ventilator. Okay. But other than that, going to the doctor doesn't help you, because we have no medications to treat this disease. There's no antivirus medication yet to fight this virus. So if your mom is relatively comfortable at the house and she's not having trouble breathing, just tell her to rest. Just tell her to rest, drink lots of fluids with electrolytes like tea, warm tea, maybe some sport drinks like Gatorade, and just rest, and hopefully this will pass. Okay, your little sister's with your mom. If your mom does have the coronavirus, and obviously we don't have any test results to confirm that, but she has some symptoms that suggest it. If she has the coronavirus, yeah, your sister has definitely been exposed. Okay, so you need to watch your sister for symptoms and see, if she starts to developing a fever or cough. And honestly, at this point, your sister should self-quarantine as well. It's a difficult time. It's going to be difficult for all of us, because, you just don't know when you've been exposed. I think about the people that work at grocery stores in the checkout lines and stuff like that, right? They're standing there for 5, 6, 7, 8 hours a day, and people are coming past them. Those people could be shedding virus all over the conveyor belt of the grocery store, and everybody's getting exposed to it, but particularly the grocery store worker at that time. So I'm very concerned about that, because we need our grocery stores to stay open, because obviously people need food. Even when you're sick, you need food. So this is a scary time, but we have no choice but to go through it, and we will. Okay. Okay, Pam. All right, you take care, and have a good weekend, and we'll see you next week. Okay. Okay. Bye for now.